Okay, now we want to talk about what happens to the slope of a graph if you reflect it through the line y equals x. Now, when we do this reflection, we assume we have equal scales on the x and y axis. 1 unit on the x-axis is equal to 1 unit on the y-axis. So if we have 2 points, x1, y1, and x2, y2, on the graph of y equals f of x, then, well, we can denote those 2 points maybe like this. Then if we reflect the function f of x to get the graph of the inverse function, this point is going to reflect through this line, and this point is going to reflect through this line. Meaning that this point will reflect to a point here, which is equidistant on an equal distance on the other side of the line, where this projection line or this reflection line, if you want, makes a right angle with this line. Now, my sketch didn't do a really good job of that. This angle looks a little bit acute. This one looks a little obtuse, and similarly for this angle and this angle. But you get the idea. So x1, y1 reflects over here to the point y1, x1, because when you invert the coordinates, reverse the coordinates, you reflect the point through this line, one of the things you were asked to prove. Okay, then x2, y2 is up here, y2, x2 is here, a reflection through this line of the x2, y2 point. Okay, well, what's the slope of this green segment? Well, it's very obvious. It's rise divided by the run. The rise is y2 minus y1. The run is x2 minus x1. So the slope is y2 minus y1 over x2 minus x1. And then the slope between these 2 points, this orange colored line, is rise divided by run. Now the rise is not y2 minus y1 over x2 minus x1 anymore, because to get the rise you have to take the difference of the y coordinates. And the y coordinates now are x1 and x2. These are the coordinates that were originally the x coordinates of these 2 points. They're now the y coordinates here, so that the slope is x2 minus x1, the difference of the y coordinates, divided by y2 minus y1, because these are now the x coordinates. So the slope is x2 minus x1 over y2 minus y1. I asked in class how that relates to this, and somebody immediately said it's a reciprocal. Yep, exactly. So this slope is the reciprocal of this. So we're going to say that the slopes of the inverse function are, in this sense, the reciprocals of the slopes of the original at corresponding points. And by that I mean, if this is a slope between 2 points of the f of x function, which is depicted now by this curve, then the inverse function curve is here. Okay? And the slope at, let's say, the slope of this function here at this point is the reciprocal of the slope of the inverse function at the corresponding point, at the reflection of that point. So we don't want to make the mistake of saying that the slope of this function for a given value of x is equal to the slope of this function for the same value of x. Our values of x for this point and this point, our x coordinates here, are clearly different. So the slope of this one at this particular x value is equal to the slope of this one at this particular x value.